I'm here today to talk about flaky tests, or more directly, that there are no flaky tests, and why is that, and why do I make such a bold statement and controversial one? Why were we so fast into sticking the flaky tag into testing? Because I don't remember to see any flaky applications or flaky environments. This is something that is really, really important. It will hide problems, because if you are believing that the test is flaky and the problem of the flakiness is the test, then you probably are hiding problems in architecture, in infrastructure, in the code itself. The test must be independent, and the results of one test cannot be used in another. And if you follow this simple approach of trying to have independent tests, you will see that it will improve how you can do things. What we did to deal with flakiness, because at the end of the day, we need to deal with it, even if it's not 100% the fault of tests. So we invest in information. Hardest thing to do is review a testing approach, because if you have too many tests, you need to cut that down, have a layered approach.
I would like to welcome all of you to the 16 virtual meetup with Cristiano, Cunha. So before that, a huge shout out to Browser Stack, who is our exclusive sponsor for all community events and premier sponsor for all conferences. Without their help, we wouldn't be able to do so many events to help you upskill yourself. Now, I would love to invite Cristiano Cunha on the stage. Cristiano is passionate about testing, automation, and delivery. I had a little talk before this session on him with him, and it was an amazing talk. And I'm sure he is going to bring an amazing session for all of you guys. So before delaying anything, I would like to call him up on the stage. Cristiano, over to you. We would love to hear your thoughts on the topic for today.
Hey, thank you for having me. Good morning, everyone. Yeah, so we are going to talk about flaky tests, and why do I think that there are no flaky tests. So it's really interesting today. So I think I can take it away. Let me share my screen. So again, thank you for the test tribe for having me. I think it's my second appearance here on one of these events. And I'm here today to talk about flaky tests, or more directly, that there are no flaky tests, and why is that, and why do I make such a bold statement and controversial one. But before we starting, let me just give you a little bit more information about me. Well, like everyone, or most of us in testing, I've started as a developer, actually quite a while ago, so I'm here for some time. But I started as a developer more on the mobile side of things, and I evolved into testing and quality, and I've been in siloed QA teams, I've been in agile teams, I've been working in automation because of my background as a developer, and my passion is really on automating the most of it and enhancing the way we're delivering software into production with quality and with reliability, and being effective doing so. So I've been a developer, a tester. I also worked in infrastructure, more on the pipeline side of things. And all of that has given me a background and a vision about the overall process and how teams interact, that I think is really interesting when I talk to people and with the community like yours. So if you want to reach me, you have my Twitter, my LinkedIn, and my blog if you want to know more about me. But let's start by understanding what is a flaky test. So the definition of a flaky test is basically a test that both passes and fails periodically without any code changes. And that means that neither the code of the test changes or the code of the application. So you're using the same environment, you're doing 2 runs, and in one run the test fails, and in the next run, a little bit time after, the test passes. So, and this behavior, it's what we call flaky. But and that behavior is really causing an uncertainty about the results. So we are not sure if we are breaking something or it's just a flaky behavior. But my question here and for you is, why were we so fast into sticking the flaky tag into testing? Because I don't remember to see any flaky applications of flaky environments. Because when flakiness happens on those two different applications or environments, we don't call them flaky, we solve it, right? So why were we so fast in gluing this flaky to testing? And that is why I'm here. And I don't believe that the tests are the automated checks, because at the end of the day, what we're talking about is automated checks, not really manual testing, because manual testing is not flaky. We are doing actions, scripted actions. So my question next is, when did you start experience flakiness? Because I remember my time when I just did one test and write that test in my machine, push it on into the version control, and then here it goes to the pipeline and run on the environment. And that test passes all of the time. But because we have one environment, really simple application, one database, nothing more fancy. And then I started adding more tests, and we needed more environments. And I needed to do a lot of code to do more tests. And most of the time, I start seeing that poor code in tests will enhance the possibility to have flakiness. So poor code is one of them. The high number of web UI tests is another one, because if we focus our testing efforts into web or UI, what we ended seeing is all of the tests starting to be flaky because the interfaces are not that fast, because we are installing that in environments that have not the same performance as the production ones. And if we have a high number of tests that take a lot to run and are high demanding for the application and the environment, it will start to have this flaky behavior. But again, remember, I'm not want to tag that flakiness to the tests. But the flakiness happens when we have multiple environments. And sometimes it's because we have, I don't know, multiple configurations. Are they applied in the same way? Do we have environments that have networking issues or not? Are we able to reach all of the services that are installed there? We will dive a little bit more on this. And well, the multiple configuration already talked about, and also the architecture complexity. So if your services have a lot of layers with cache, with database, with messaging, with APIs, with UI, and all of that is extra hoops for your application to go through in order to work. And the test will need to go through all of those hoops. And if some in the middle of it, some misconfiguration happens, some lack of connectivity happens, the flakiness will appear. But it's not due to the testing. Well, not 100% due to the testing. And you know, when the flakiness happened, at least for me, it's really when I needed it. I need to have the tests working. It's when the flakiness really happen, because when I want to release, it's when I start see flakiness. And that's really, really hard, because it's a test that is failing and the next one it's not. So will I block the release or not? And then we get a hard time searching for it. But so we have stated that, well, flakiness happens. I don't want to give the culprit of the flakiness to the tests, but flakiness happens, and there are risks with this flakiness. If we see of not solving the flakiness, because when you start having a test that fails for no reason in a given time and passes for no reason also, the whole team and the company start to have lack of confidence in the tests that are put it in your pipeline or in your process. And that when you lose the confidence in tests, it's really, really hard to get it back. Like everything in life, right? When you lose confidence, it's really, really hard to get it back. So, and this is the hardest thing when you have these flaky tests. And I see a lot of persons just, I don't know, rerunning those until they passed, or using that pipeline run that have everything green and it's good, even if after the tests have failed, because they need to get things out of the door. But the lack of confidence is really, really hard to have. And like I said before, it will delay your deliveries, because if you are just waiting for the results to deliver something to production and you start to have some fails, some tests failing, some other not, you will see that the delivery will be delayed, and then you have to remove those tests or treat them and do the manual validations or have another way of dealing with them. So the delay is something that will happen for sure. And it will cost you money, because your testers, your team will need to look at it. The maintenance of tests will be hard. The delivery, if it's delayed, will cost you money also. So it's everything that you don't want to happen. And of course, this is something that is really, really important. It will hide problems, because if you are believing that the test is flaky and the problem of the flakiness is the test, then you probably are hiding problems in architecture, in infrastructure, in the code itself. Because we will see that the flakiness happens, but it's not a problem with the test. But let's deconstruct this flaky test. So we have flaky, that is usually associated with unreliable. And here the test will be more of an automated check, because at the end of the day, the flakiness, it's more of a statistical way of looking at things, because we need a lot of runs in order to understand if this test or the automated check is stable or not, and if it's reliable or not. So this will get you to have unreliable automated checks. And this is really, really hard for me to cope when I start hearing about flaky tests, because automated checks are code. And like I said in the beginning, I never heard about flaky applications, even though they are based on code also. So why? And I start wondering, why do we have flaky tests? At the end of the day, it's code. So why can we not solve it? What is there that we are unable to solve that gives this unreliable way of doing things? What's happening there? And my question is, why do we blame the tests or the checks? But before continuing, and if we are not blaming the tests and the checks, like I said, we need to look at the systems. So if the tests have found a flaky behavior, they have found a flaky behavior of the system that you are testing. And what are these systems that I'm talking about? So systems here are actually, what I want to talk about is the social technical system. Because nowadays, an environment is not just, a system is not just an environment. Your organization is not just a system. So we need to consider the structure in here, representative of the organization, of your structure of your organization. You have the people, and this is more on the social system of the social line of the system. So all of these parts interact and make your whole system. You have your organization, you have your people, you have your physical system when we have all of your infrastructure, all of the hardware that you have there, and you have tasks. So tasks here are things that people are doing to interact with the system. And all of this is your socio-technical system. And this socio-technical system are really what we have nowadays, because we are entering the realm of socio-technical systems, where a tool is not only valuable anymore for the technical aspect of it, but also on how it will handle the interaction between people and technology. And we will see that everything is connected. And why are we blaming the messenger, in this case automated checks, for finding a flaky behavior of the system instead of looking where is this flaky behavior coming from? So this is really, really important for me. And if anything else you take from this session is start deconstructing this flaky tests association to the automated checks and start asking why does it has failed sometimes? Does it mean that we have something on our system that is not that reliable as it should be? And the automated check is finding this. And sometimes we are just not considering it because we associate the test. We think that the test is really the one that is flaky. But most of the time, if not all the time, it's hinting you that something is not right on your system. Because flakiness is valuable information. Like I said, the system is telling you something, and we need to listen. Because if you have performance or concurrence issues, you will see that the application will behave differently. And most of the time, we will see slower applications on development or quality environments and faster applications in production, because the environment where they are running from are not equal. So usually, and what I've seen in most companies is in QA environments, in development environments, the infrastructure itself, it's shrinked to the minimum because of costs, of course, and the application needs to cope with it. And when we try to do or interact with that application, it will be slower, but it should be slower and the test must cope with it. So even if you are writing automated checks, you need to be aware of it. And you need to understand this, if it's really a performance issue due to the size of the environment, for instance, or do you have a performance issue of your application? And you are just hiding it because you're tagging the flakiness to the tests. And one that happens a lot to me in mobile was memory leaks. And this was really hard to understand. And what are memory leaks? It's usually the application starts consuming a certain amount of memory, and then while the time is going by and the application is just running normally, even without interactions, it starts consuming more memory and more memory and more memory until it just goes out of memory and the application crashes or give strange behaviors. And this usually happens when we didn't have garbage collector, for instance, in our frameworks or tools. I believe most of them have now. But even when we have, like, if you have a grid and you are using it, and in your test you're never closing the WebDriver, it will accumulate all of those WebDrivers. And at the end, you'll see that your tests are not that performant or stable as they used to be, because there are so many WebDrivers open, instances open, that it will start to have strange behaviors. Another thing, it's incorrect configurations, and I've dealt a lot about it, because when we have, for instance, automated deploys where we have multiple environments considering in your process, you need to have different ways to apply configurations, because you will use different databases in QA environments, different databases in development environment, and of course in production. And if you don't apply the right configurations to the right environments, you will see that your application will start not behaving like it should. And sometimes it kind of works and you don't know why, and it fails and you don't know why. So configurations are also something that you need to consider. But again, you need to listen to what the system is telling you about. And the hardest thing that happened when flakiness hits me is problems that are hard to replicate. That is the whole base of the flakiness, because if sometimes it passes and sometimes it don't, it's hard to replicate the exact steps, so the exact system that we have in place in order to replicate the failure. But let's see what really is causing the flaky behavior. As we've seen, socio-technical systems are now composed not only by hardware and software, but also by physical surroundings, by people, procedures. And I even put in laws and regulations, because your system will be indirectly affected by it, because you need to have in your code, in your application, that you need to obey to laws and regulations that actually will make it work differently because of that. And of course, a big one that is data and data structure, because all of the data that you have in your environments, in your tests, in order for your tests to work or to fail, depending on what you want to do, it's really, really important. But for me, let's just consider 3 angles of it and how can we address flakiness in each one of them. I will see on the test side, so on the automated checks, on the infrastructure side, so all of the things that are related with environments, and on the target applications. That is one that sometimes we forget because we are just validating it. So on the test side, we often have seen that the problem lies on the approach mentality that we use to start the automation effort. Because the biggest mistake I usually see when we are, what I see, the biggest mistake is when we are asked to convert the manual tests into automated checks. If we do that blindly and just convert that into automated checks, and the manual tests will directly correspond to web tests, so UI tests. So if we convert all of that in automated web tests, it will give a big number of tests that will take a lot of time interacting with UI, and it's not the best way to do things. So you need to focus on a layered approach. You need to use multiple test types that, when added up, will validate what we need, instead of trying to validate everything on the web layer. Another thing that really can cause flakiness on the test side is rely on the test order. And I've seen this happening sometimes, because relying on the test order to get the job done is never good, because the test must be independent, and the results of one test cannot be used in another. And if you follow this simple approach of trying to have independent tests, you'll see that it will improve how you can do things. And of course, having independent tests will allow you to run them in parallel and will save you a lot of time, for sure. The data of the test is really, really important also. In my previous company, we used to fetch data from production, and we need to mask that data, to shrink that data, to put that data into different environments in order to have valuable data for the tests to work with. But it's not that easy, because data sometimes is not that easy. It's not picking up that data and pushing it up to different environments. Well, if you have the same capacity of environments, it will, but because you need to shrink it and the data have dependencies between them, it's hard sometimes to, well, if you are in an e-commerce site, to extract orders to extract the product of those orders, to extract the prices and the sizes of those orders, when you are just looking at raw data in the database, and the database masters are just trying to shrink that and put it available on your development. And also masking sometimes does not work that well. If we have to mask, I don't know, the user, and you have to mask the user in the login, the user in the orders, and do all of that connections back. If some of that fails and your tests start failing because of it, it will be bad for sure. And one that is the only one that can, or that I'm willing to give and to tag the tests as flaky, is poor code quality. And poor code quality of the automated checks. If you are building automated checks, remember that code is an art, and the artisans that are behind it need to understand the good standards, need to understand how you do code right, that is maintainable, that is reusable, and that is reliable. So automated checks are also code, and you need to have best practices in place in order to have the best tests in place. And the most common mistake that we have in this automated checks in the web layer is waiting. Because if you are not actively waiting for an element to appear in order to interact with it, you will probably fail sometimes it won't. And this active wait sometimes is not just the fact that you are adding a waiting for a determined element to arrive, but it's also that you need to understand how you are searching for that element if you're using XPath or anything like that, and understanding what's the best way, because sometimes XPath is so heavy in order to parse all of the DOM of the page, that will take so much time that sometimes it will just stop working because of it. So you need to be fast, you need to be, and the way that you find it, if you rely on the structure of the DOM, that will change for sure. It will not be maintainable. But I have a lot of other things to say. And about poor code quality, but we will see how to address it a little bit afterwards. Lack of collaboration is one of those, because if you are just in a team that are just tossing the production, the release to the test side, and the testers and development team are not collaborating, are not talking to each other about it, we will see that the test that the quality team is putting forward sometimes are the possible ones, are not the optimal ones. Because sometimes we will really appreciate if we'll have an ID on the web in order for us to catch those elements in a unique way and in a reliable way. But if we don't talk with development team to have those, probably we will hack a way of making that work that will rely on a lot of maintenance. And sometimes they are more tricky things. So we are into the realm of testability. So how testable is your application? Have you talked about it with your development team? Because sometimes when you are going through, I don't know, an authentication flow in your web application, and you see that the only way to authenticate a user is you need all of your tests to do authentication on the web and then do the test. If for some reason those tests start failing on authentication, you will see, I don't know, that the adding to the basket is failing, when in reality the login is the one that is failing, but the tests that you have built rely on the login in order to do the rest, and this is really misleading. So why not talk with the development team and start talking about how can we do this without the UI? Can you have an API, for instance, and it happened to me, can you put an API available for me to do the authentication through the API and then just do the interaction on the web page in order to add to the basket. Things like that had the testability will enhance the way that we do tests and reduce the flaky behavior of the tests. On the other side, we have also flaky behaviors of the infrastructure. And this one's a little bit tricky to find because, well, sometimes, and depending on how, let's talk about environments now, because at the end of the day, we need an environment where the application is installed, and we need an environment where the test will be running. So at least two environments we will need to have that need to communicate between them. So network configurations go a long way. And connectivity instead of just network configuration. So connectivity go a long way. If you have, and if we go to the Kubernetes side and you need a lot of pods to interact with each other, with a lot of microservices that will need to interact with each other, we need to make sure that all of the pods are communicating correctly. We need to know that the database that they are connecting to are available for each one of these microservices. We need to know that the pod where we launch the tests have connections to or have routes to the application. And if in this web of microservices, if we are going to the extreme, if one of those connections between two microservices is failing, and we have layers of microservices that interact with each other, how hard is it to find that missing network configuration when you are just exercising the web interface? It's really, really hard. So look at connectivity, look at accesses, because sometimes in those environments, you need to have pre-provisioned users with correct accesses or test users for correct accesses in order to interact with the application in the right way. So do we have that provisioned, or is it correctly provisioned? Because sometimes it's not that well, and that will cause flakiness for sure. Authorization is another thing. So it links a little bit with access, but authorization is a little bit different. So do we have application, like I have a lot of issues with applications connecting to database with the wrong authorization, meaning that sometimes they cannot, create index, they are just reading permissions. So having the right authorizations is something that we need to have processes around in order to make sure that in each environment where we are doing deployment, we have the right ones in order to try to cope with this. And data manipulation, like I said, and I put it here and I put it in tests because it's a little bit intertwined, because sometimes we will need to inject data in the test, through the test in the infrastructure in order to have the test passing. And sometimes we will need to have data pre-provisioned in the environment in order to have a more production-like experience. And sometimes, like I said, it fails because of the masking of it. Sometimes we don't have that possibility to, the masking is not that well done, and sometimes the links are lost, the dependencies are lost because of it, and the test will not work as usual. And this will cause flakiness also. And the last one is sizing. Like I said before, for me, I never saw a production-like environment ready to or available for anyone in development or QA to do their tests, because you need to have smaller environments with less CPU, with less disk, less memory. And one of the things that was causing flakiness for me, we have memory leaks that I already talked about. High usage of CPU is another one. And one that was funny is one of the microservices was using all of the disk space that it has available on this partition, and it stops. So it stops doing the authentication because of it. And it was hard to understand why the authentication was failing, and reach to, the application cannot write logs. So it started failing not only the authentication, but the overall microservices was just in a very strange way, because it will something was happening also on the system that was freeing up bits of disk, but automatically that chunk was used to logging, so it worked for some time, but then it's not working. So make sure that you have, even if it's downsized, you have enough memory, CPU, and disk for your application to run, for your tests to interact with it, and understand that probably your application will be slower and the tests will need, or the automated checks will need to cope with it. And finally, application. Because sometimes we have those memory leaks on the application. Like I said, if you have the application consuming memory, and usually when you go to those observability of those monitoring tools, you will see that the application has a pattern of consumption of memory. And if you see a staircase pattern, well, it goes up, plateaus, and then goes up and plateaus, and goes up and plateaus until it consumes all of the memory. You have a leak there. Or if it's just exponential, so it's just consuming until it explodes, you have a memory leak there. And sometimes the application is just running. You're not even interacting with it. So it's really, really important to make sure that that doesn't happen. And sometimes it's just triggered by an action. I've seen sometimes that when you do an action on the application, it starts consuming the memory until it bursts. So make sure that you don't have those. Deployment issues. In here, I was a little bit on the fence on putting this on infrastructure on the application. But for me, the deployment is a responsibility of the application. The application must know how to deploy itself. It must have automation around it. It must know how to apply different configurations to different environments. It must know how to do the deployment. And because if the application is not deployed with success, you'll probably will have flakiness on your environment, or even just an environment that is not ready to use. And one of the things that we did was what we call a readiness probe. So after each deployment that we do, automated deploys in the pipeline, we have a readiness probe. For us was just, well, it was an e-commerce site. We were going to the main page and to a listing page and making sure that it's returning what we expected to do. And that was giving us at least the minimal assurance that the application was deployed with success. Because sometimes we try to go to the main page and it returns an error. So why is the deployment saying everything was deployed, but then the application is not running as we expected it to do? So the deployment for me is really a big thing. Make sure that you have mechanisms to do an automated deploy and to validate that deploy. And only after that validation that you must return that the deployment is okay. And finally, of course, actual issues on the targeted app. So, and this is why Flaky is so hurtful, because it makes it hard to understand if you have issues on the targeted application. So what we did to deal with flakiness, because at the end of the day, we need to deal with it, even if it's not 100% the fault of tests. So we invest in information. We had meaningful logs. So meaningful logs is not just logs of the application. It's logs of the tests, log of infrastructure, and make those available. Because like we saw in the socio-technical systems, we need to have all the information available in order to gather and see where is it coming from. Because when the test is running, the application is consuming a lot of memory, or we can see on the infrastructure logs what was causing that. And make that available for the entire team is something that we needed to do in order to try to understand what was causing this flakiness. So information is really important. And we did this adding the right logs to the test, to the application, that are meaningful, that have the right information for us to take the right decisions. And on the test side, we also had information whenever we think it was valuable. So screenshots, video, or traces. because sometimes an image is really, really helpful to understand, well, oh yeah, it still hasn't loaded the page, so it's probably an issue. Or, well, it never loads the button that I'm expecting to. Or I'm not in the page that I think I was. So all of those things are really important information. And create insightful reports, because most of the time when the test is running on the pipeline, what you see is the end result. So we are running 100 tests, and what we see is, well, it has passed or not. And you need to go there to look at the report. And if you have all of that information that we just talked about, logs, adding information in tests, you'll be able to build a report that have enough information for you to pinpoint the issue. And that is really, really important in order to deconstruct this flakiness information. On the second thing, invest in code. Like I said, tests or automated checks are code. So you need to review the test code. Check if you have incorrect assertions, if you are doing the right assertions or not. Check the code and take advice from your developers, because they are the ones used to build code. If you have built it and you are not that familiar with it, run them through your developer peers, because they will help you create code that is up to the standards. Make sure that you have active waits. Make sure that every time in your test, you know what you are searching for and you are sure where you are at. So adding the active waits will go a long way. And make sure that the search methods for each one of the elements that you want to interact with are correct and not taking a lot of time for you to go. And this will, having this, review the test code, and it will be really, really, it will see that a little bit. We will see that if you share the good practices and the corrections that you did when you find a test that is flakiness, and you generate a good practices handbook with examples saying, well, we have this code in the test, it was generating a flakiness behavior, we did this, and now it is solved. So if you have this, please try to apply this correction. And making this available for the entire team is really, really valuable and helpful. And work with development teams. So we need to increase testability. Like I said before, make sure that you have the right ways to test your application in the most optimal possible way. And do this by sharing sessions. You need to share this with all of the teams. Share the best practices. Share what you find. How do you solve it? Because they will learn from what you did and will prevent errors from happening in the code. And because we need to cope with flakiness, we have also created a quarantine strategy. Well, what does that mean? In order for us to deconstruct this culprit flakiness of the automated checks, we need to create a strategy. So we added a quarantine tag to the tests to put tests in quarantine. In quarantine means that they are not executed. But in order for you to put that tag, the code review must be done by your peers, and you need to add a manual test while we have the automated check in quarantine. So if you are removing an automated check, adding the quarantine tag, that means it will not be executed. You need to add a manual test in order for that area to be covered. And if it hurts, it will not be forgotten, because sometimes when you have these quarantine strategies and you are just adding quarantine tags to the tests, and they just are forgotten there and never solved. So if you have the manual tests, and the guys that are doing manual validations have one more test that they need to do that could be covered by automated, but it's not because it's in quarantine waiting to be fixed, it will help a lot. And also have a job that will execute the quarantine tests in loop and register the results. Because the thing is, if you think the problem is in the automated check, you do a correction and you see that the next run it will pass, is it really fixed? We're not sure. So we need to run that, I don't know, 100 times, 200 times to make sure that statistically that test will be always green. And the hardest thing to do is review your testing approach. Because if you have too many tests, you need to cut that down, have a layered approach, try to add unit tests, try to add component tests, try to build up confidence in each one of the microservices in order to have only one or two UI or web validations on the top. Try to build atomic tests that are independent from each other, that are focused on what you want to test, and shift left. So add the amount of tests closer to the code, like unit tests that are doing faster validations, and that will get most of it in the code. And of course, we have one approach that is, well, rerun tests, because sometimes, and we have some tools that just does this for you. But my suggestion is, well, don't do that. Never rerun tests until they pass, because you are, like I said, you are just hiding information that's really valuable for you and for your team. So my final words, if you guys can help me, or if everyone out there can help me deconstruct this and start saying that we found a flaky behavior in the system and the tests have found it, and let's give the test a possible doubt. So probably the test is not flaky, probably something in the behavior is, in the system is. So what is it? How can I find it? How can I stop this flakiness to happen? So look at the tests. Code quality is really important. The only thing that I see that is inputted to tests is if the code quality is not what we want it to be, the test will be flaky. That I will give. But from what I see, if you have right code in the tests, right approach, most of the time, or I don't know, 98% of the time, the issue is not with the tests. It's with something else. And you need to be smart about it. You need to have processes around it to let you understand what is causing that. And sometimes you will discover really, really good things that will help your application, will help the overall system to work better because of it. So we have tests, code quality, information, shift left, layers approach. So look at your tests, make sure that they are not a problem. Look at your infrastructure, how data is put there, how are the connections, how are the users, what information can we extract and save from it that will have you everything in there. Look at your application. Make sure that you have bulletproof deploys, because the deployment is one of the things that we must rely on. If it's green, we must be sure that the deployment is done successfully, the application is running successfully with the right connections, with the right database, with everything working as expected. I don't want to click on the main page and that just explodes. Make sure that you collaborate with your development team. Make sure that you have channels where you can communicate with them in order to increase the stability of applications, and also helping or getting the help into the code that you maybe have on your tests. So let's change this and say, well, I found a flaky behavior in the system. Remember, you need to have ways to cope with flakiness, and if you have quarantine tags and running all of that, but make sure that you address that. Make sure that you remove each one of these bits until you find the culprit for that flakiness. If it's the code quality of tests, fix it. If it's something in infrastructure, show it to your operations, show it to your application, to your development teams, and say, well, I found this. How can we cope with it? If it's something just on development, it's hurting you. It's hurting the company because it's taking you time to analyze. It's taking you time every time you run things. So even if it's not production, you need to have that working. And what we did also on those different environments is, if you take one of those environments and it's always broken, why do you have that environment? Because it will just it's a um, never ending way of making you lose time solving this, solving that, solving the other thing. So make sure that you bring that up and make those changes. And it's all that I have for you. Once again, you have all of my contacts there. I hope you liked the presentation. This is really a thing that is close to my heart. And I was part of automation team. I was leading an automation team that we built custom framework for all of the development teams to use, and we start to be heated by this flakiness, and we have to defend ourselves, and we did it like I told you to. So we create a quarantine strategy, we address each and every tests, and we gather with the team and showing, well, this is failing because of this. If we do this, this will be solved. And you'll see that the mentality will start to change and the confidence will start to go up. But it's a never-ending work because we are always changing, always adding things. And that's it for me. Thank you.
Thank you so much, Cristiano. That was a great session by you. So we have few questions that I would like to take up. First, we have a question from Gunesh. The question is, can implementing a good unit component testing strategy help with flakiness?
Yeah, well, for sure. I think that, like I said, you have to have a layered approach, and the shift left for me is everything. So you need to invest in the right places, and having good unit and component testing will help a lot. But you need to combine that with the rest of the layers in order to have less flakiness. And that approach, that way of looking at things, will also change your mentality regarding how you will look at testing. Because, like I said, if you just trying to do or to put in automation what you do manually, it will not work. So we need to deconstruct that. You need to divide to conquer. So we need to build up confidence on those small bits of layers. And adding unit tests, adding component tests will have you understand that for that microservice or that application, that is working. So what it will bring you is focus. It will allow you to understand that if this service is validated and this service is validated, but when we interact with both, something is not right, I will automatically take out the behavior of each one of the service and focus on the interaction, because I'm sure that the validations are okay. So yeah, it goes a long way. You need to invest on different layers of testing. Unit test is one of them. Component test is another one. And the approach, if you start doing this, but not rely only on unit tests, it's not enough. But if you start to have all of these layers around and build up confidence, you'll see that the flakiness will shrink down also. But make sure, like I said, don't focus only on testing. Focus also on the infrastructure, on the application. Understand how all the system is working.
Understood. We have another question from Madhu. The question is how to identify the system before flaky test, so to avoid fail if it is possible.
So that's a good question, because like I said, it's a complicated system, and to understand what to look at and what to focus on, because it's a big system. But you need, if you have been working with that application for some time, we'll start to understand what it needs to run. And this, you may need some help depending on how technical you are with your development team or your team, if you are in an agile environment, to understand what kind of connections, how are the interactions with the different services, how are the databases, how is the deployment process. Sometimes the deployment process tells you a lot about what the application needs to be running. what are the connections that it needs to, the different services, the dependencies, the database, all of the configurations there will hint you about what the application needs to be running. And that will translate into necessities to infrastructure. And that will translate into understanding that bit of the system in order for you to execute the tests against. So I will say that try to understand the application, what are the dependencies, and when I talk dependencies, is not other applications or microservices, but also data, connections, all of those things. Because, and I know external dependencies are really important also. Sometimes I've been using like authentication to, so it was an outsourced authentication, and we had like a sandbox that was made available by them for us for our internal environments. So we did a call to that sandbox to authenticate our users, and they return okay or not, and we'd continue our process. But the sandbox was not that stable, and it was sometimes taking a lot of time just to do that communication. So sometimes smaller things like this are all information that is valuable. And one other thing that is a little bit out of the topic, but not out of the topic, out of the question, is also treat your internal environments like production ones. Don't let that, oh, it's always broken. Oh, you need to do one or other things to have that working. That is taking you time every time the release is going out. So, and one of the times in one of the meetings what we have, well, QA is broke, and who did that deployment that broke everything? And I suggested, well, why don't we have an on-call for the QA environment, and each time it's broken, we do even out of hours, we are called in and we see what was wrong. And no one was able or wanting to do that because it was so hard to have that working. But if you manage to have, because sometimes, you have one QA environment, and then if you don't control who is deploying there, who is testing there, and changing the environment while you are testing, it will bring instability also. So it has a lot to do with it, and it can come from different sources, but you need to be aware of it.
Understood. I hope that answers your question, Madhu. We have one last question from Amit. How to segregate the login test, because we have to log in before any other test?
So yeah, it's like one of the things that I talked about is you can validate that the login service is working and making sure that it's working. And then if you are able to do the login without using the UI, it will give you the confidence that you are focusing on what we are doing, instead of, because I've been there. So every time I needed to add things to the basket, I need to authenticate a user, add things to the basket, and talking about an e-commerce application, add things to the basket. And every time I need to interact with something of a user, I need to log in. But if the login is not that stable, sometimes I have tests that I called validate, that I'm adding product, sales product to the basket, and it fails. And I go and check, and it fails on the first step, it's authentication. And it's, why am I looking at the checkout process and it's failing on login? So, and this is one of the things that you need to do if you are running tests not in parallel, so sequentially. Try to put those tests first. So do the login. If that fails, stop it, because all of the other tests will, and that will save you time. If you're running in parallel, try to invest in tests, making sure that the login service is working. So if you have 100% sure that login service is working, but then we invoke them on the UI and it's failing, then you know that is the integration. Some connection, some database is not correctly configured. So that is easily put. But it's not hard to segregate. But if the login usually is a service, so you need to make sure that that service is okay and the release is okay. And then if you can work with that team in order to speed up things and to make things easier to do a call in your API just to have, I don't know, a cookie, to have a token, and then use that on all of the other tests. It will be faster, and it will take out that interaction that you need to do the login. It's not 100% independent per se, because it's something that you need to do all of the time. But if you start focusing on quality of each one of the services, you will build up quality when you test the interaction between them, and will be able to focus on the problem when it comes, instead of just searching everywhere.
Understood. Thank you so much for that answer, Cristiano. And anyone who has any questions regarding this topic, so the link is in the chat for the Discord. It is pinned above. We can connect there, we can network there, and you can ask your questions there. So do join in the voice channel, and you can have a one-on-one conversation with Cristiano also about your questions. So thank you so much, Cristiano. That was a great session. We had a talk before this, the session, and now I understand a little bit more about this topic. So thank you so much for that. And I'm seeing in the chat that the people loved it a lot. So thank you for doing this with us. Hopefully, we can do more such sessions with you soon. Thank you, Cristiano. Bye.
Thank
Meet you on
you.
the Discord. Meet and greet.
Yeah, we'll talk on the Discord. Bye, guys. Thank
Yeah.
you.